In this episode, we'll begin our investigation into the F# programming language and also learn some functional programming concepts. Stay tuned to learn more. What's up, everybody? My name is David Wilson, and welcome to the inaugural episode of the Dev Aspect. The purpose of this show is to discuss interesting programming languages, platforms, and development tools so that together we'll gain a deeper understanding of the software development universe. And it's also kind of a nice structured way for me to learn cool stuff. So one thing I'd like to say right up front is that I'd like for the show to function more like a conversation between us. So if there's anything I cover that you're not very familiar with and I didn't cover it deeply enough and you'd like to know more about it, just leave a note in the comments and I'll try to discuss it in more detail in a future episode. And if you sort of are an expert in the topic and you're screaming at the screen, "God, you idiot, why didn't you cover that one thing?" Then let me know and I'll try to make it up to you. So before jumping into the details about F#, I'd like to set some expectations about how I'm going to cover programming languages on this show. My goal isn't to actually teach you exactly how to write code in any programming language. Really, the goal is to teach you the interesting features about a programming language and how it changes the design of the code that you write. This conceptual understanding of programming language features and design paradigms will ultimately help you write better code in the language that you're stuck using in your day-to-day jobs. However, I do think it's good to actually investigate these languages more deeply because the more you learn, the better you become at software development. And you might actually find a language that you really like to use for your side projects. Now, let's move on to the important part of this episode, the introduction to functional programming with F#. So F# is a multi-paradigm programming language. And what that means is that it takes parts of different programming languages and puts them together into one language that can do different types of code design. So F# is primarily a functional programming language. It was designed for that purpose. But it also can do object-oriented programming. So it can do things like classes and interfaces and stuff like that. And it also has the ability to do some level of imperative programming, but generally you wouldn't do any imperative programming in F# because it's not really designed for that. This language was created by a group in Microsoft Research led by Don Syme, and it is a derivative of the ML family of programming languages. And ML is generally a type of functional programming language that has a very sort of concise syntax and has some really nice features to make it really expressive to write really powerful code. But F# owes most of its language design to OCaml because like the very first version of F# was almost like OCaml for .NET. The interesting thing about F# is that it's a part of the .NET ecosystem. So it was designed to be a functional programming language that runs on .NET. So it means that it has the ability to interoperate with C# and Visual Basic and anything else that's written in .NET. The other benefit is that you actually have access to all the existing tools and libraries that exist in the .NET world. So basically anything that's available on NuGet you can use in your F# application. So it makes it really powerful for writing actual practical application code, which is different than other functional languages that are more academic in nature and don't really have such a strong ecosystem built around it. So what is functional programming? Functional programming is a style of programming that uses functions as the basic unit of abstraction. And to contrast that against an object-oriented language, like say for instance C#, an object-oriented language uses classes as the basic unit of abstraction. So you design all of your application code around classes as the thing that you use for encapsulation and your contracts between different subcomponents of your application, that sort of thing. With a functional language, you're basically building up layers of logic using functions. And then you're using some other functions that can take functions as parameters to build your abstractions and build your more complicated logic. Also, one primary goal of functional languages is to minimize the use of mutable state. And if you don't know what mutable state is like these shared variables and shared objects that get passed around in your application whenever you're writing your code. The problem with mutable state is that whenever you pass like a reference to an object between different classes, they all have access to that same object at the same time. And this can be problematic whenever one component is changing a variable in that object when another component needs to read it. It can cause really weird problems in behavior whenever you have this dependency on the same copy of an object. So in a functional programming language, everything is really based on immutable data structures, which means if you have a reference to a data structure like a dictionary or a list, if someone else changes that list, it doesn't actually change what you have access to. It means that your reference to this is referring to that state of this collection at that state in time. So it's very different. It really changes the way that you design your code, and it actually makes it more difficult in some ways. But what you'll find over time is the more you base your code on the use of immutable data structures, the more stable it's going to be, and the more robust your code is going to be overall. So writing code in this way can greatly improve the quality and stability of the applications that you write. And the cool thing is that it actually helps you write better object-oriented and imperative code, because it teaches you some things about how to structure your code effectively, and those things can also be taken over to use in these other programming paradigms. So it's really useful to learn this type of programming. I think F# is a great language to learn functional programming with, because it's really clear, and like I said before, it has access to all the normal stuff that you would want to use. So by learning F#, we actually will learn a lot more about functional programming concepts. So I'm going to try to do both of these things at once in this episode and show you things about functional programming while teaching you the F# features at the same time. So before we jump into the code, I want to show you how to get an F# development environment set up on your machine so that you can follow along with the examples that we go through. It's really easy, so we'll go over to the computer now to check it out. All right, so the best place to get started in using F# is to go to fsharp.org. This is sort of the central website for the language, and it has a lot of good documentation and sort of getting started guides so that you can learn how to use F#. So if you go to the Use menu at the top of the navigation place, you can find that there's a list of installation instructions for different platforms. So if you're running on Windows, you can click F# on Windows and see all of the options you have for installing. So if you're on Windows and you use Visual Studio, then you can use the Visual F# tools, which will install the compiler and the interpreter and everything that you need. But if you don't use Visual Studio, you could actually install just the compiler and tools by themselves without actually having to install all the rest of the stuff for Visual Studio. So once you have F# installed on your machine, the editor that I highly recommend for editing F# code is called Visual Studio Code. So you should go and download version 1.4, which just got released. And Visual Studio Code works on Windows, Mac, and Linux. So you should be able to find an installation package for whatever platform you use primarily. So for editing F# code, what you'll want to use is the Ionide extension. So this is a really great extension written by Krzysztof Cieślak and the F# community. And it provides everything from IntelliSense for F# to interactive code execution and debugging and code navigation. So it's really good for really quickly developing some F# code. Okay, so let's get started. So we're here in Visual Studio Code. And the first thing I want to show you about F# is just the very basics. So let's look at how to define a variable. So the syntax is very simple. You just type let a equals 10. So this is defined a variable with a value of 10. And if you hover over the letter A, it will tell you that this is an integer. And F# has really nice type inference. So you don't really need to specify exactly what type you're using most of the time. The F# compiler can actually figure out what the type of any variable should be. So one thing that is interesting to note about this is that even though I'm calling a variable, you can't actually change it. So if we type in a equals 20, we'll see, oh, look, there's a gray squiggly or a green squiggly here. If we hover over it, it says the expression should have type unit, but has type bool. So immediately we see that there's something wrong here. Well, it turns out that the equal sign is not actually an assignment operator in F#. It's actually the equality operator. So that's different from other languages you might be used to. So since we can't use the equal sign to do assignment, what we need to do is use the arrow. And this is what actually would allow us to do assignment in F#. But what you see here is that it says that the value is not mutable. And this is because we've defined a binding from the name A to the value 10. And this binding is not a variable. It cannot be changed. So if you actually want to make a variable that you can change, you have to use the mutable keyword. This actually will define a variable that you can change. And I kind of like this because it makes you really think about whether you want a variable or a binding to be mutable or not. This has a lot of impact on whether your code is going to be able to change variables while it's doing some computations. And it sort of discourages you from using mutable variables whenever you don't really need to. So definitely keep an eye out for this whenever you're learning F# because it could be something that might be confusing. So the next thing to note is that bigger objects like collections are also immutable. You can't change them easily. So if I define a list called items and use F#'s arrange operator to create a list that contains the values 1 through 5, I can go and say list.append. I want to append to the list called items another list with the value 6 inside of it. So let me go ahead and evaluate this. And the nice thing about the Ionide extension is if you go into the command palette in VS Code and type in FSI, you'll see that there are a few different options for being able to evaluate code in real time within VS Code. You'll see that there's the send file command, there's send line, and there's also send selection. So in this case, I just want to send the line, and this is bound to Alt and slash, so that actually makes it a little bit easier to get to. So I'll run this command now, and this output pane pops up, and this will show us that we have a list that contains values 1 to 5. So if I run this next line that has the list.append, you'll see that it returns a list containing 1 through 6. And that's great, because that's sort of what we wanted, right? But does it actually change the items variable? Let's evaluate items to see what it contains right now. So if we evaluate items, we can see here that it only contains 1 through 5. So this variable has not been changed, or the collection that's stored inside of the name has not been changed. So you basically have to use a mutable variable if you want to change this collection. And anyone who actually has a reference to this collection before I run the append operation, they will still have the original 1 to 5 list because the list that they have has not been changed. It can't be changed. So this is a very interesting thing about functional languages that use immutable data structures. It's definitely a thing to keep in mind because you might be pulling your hair out trying to figure out why a list is not being changed when you're trying to add items to it. Okay, so now let's define a function. So just for the sake of fun, we'll make a function called prefix, which takes a prefix string and also takes a base string, and then it will basically add the prefix string to the base string with a little bit of a string in between. And you can see that this is a valid function. We get no warnings or errors or anything. So if I hover over the name prefix, it will tell me that I have something bound to a name prefix, and it's a function that takes in a string, or actually 2 strings, and then returns a string. So F# was able to figure all that out on its own. I didn't have to say that I accept strings and return strings. It does all that perfectly. So if I want to try to use that, I can say prefix hello David. And now I'll go and select this code and execute it. And you can see that the prefix method returned hello David, which is cool. And you can sort of see how the syntax of F# is really clean and straightforward. Because you don't need to worry about putting type definitions everywhere, and you don't need to worry about curly braces, the code ends up looking a lot like Python. In fact, I think it looks even cleaner than Python. So this is sort of a really interesting benefit about F# is that you can write really concise code that actually is pretty powerful. The other nice thing is that F# is a strongly typed language. So if I go and try to put an integer here, it's going to give me an error saying that the expression was expected to have type string here, but has type int. So even though I did not specify at all what type of variable prefix string or base string were, F# was able to figure that out based on the contents of the function, the operations that I performed on those parameters. And now whenever I try to use this function with a variable type that it is not expecting, it will give me an error. So it's almost like you get the benefits of a dynamic language with a really concise syntax, but then it's at the same time you get the benefits of strong typing and compile time checking. So it's really, really interesting. So let's move on and look at how we can use this function to do some more things. So I'm going to create this list of names that has 3 names in it. And I want to loop over this list of names and use this prefix method. So F# has this really interesting operator called the pipeline operator, which allows you to take the results of a value or a function and then send it through to another function. And you're basically able to build a chain of functions that are operating on like a collection or a value. So in this case, I can type in names. Then I'll drop down to the next line and use this pipeline operator. Then I can say seq.map prefix hello. And I'll put parentheses around this so that it's clear where the function is. So now if I execute this, let's do all of this. Let me try one more time. Then you'll see that we get a sequence of strings that actually have used the prefix method. So we're using this sequence.map function to iterate over each item of the names list, and then use this prefix method to print out these, or to create the next string, which is hello David, hello Maria, etc. So one thing you may be noticing here is that I'm calling this prefix function, but I'm not giving it 2 parameters. This is an instance of a feature in functional programming languages called partial application. And basically what this is doing is it's allowing you to call a function but not give it all of its parameters and have it return basically a new function that then has the parameters you've already specified fixed, so that whenever you call the function that it returns, then it completes the execution. Now this may sound a little bit confusing, but it's better to look at this from the perspective of how the functions get constructed. So function definitions in F# make use of a property called currying. And if you hover over the prefix variable, you'll notice that we have this prefix string parameter with an arrow, then the base string parameter and an arrow, and then string, which is the return type. So this looks a little strange, right? You know, you would normally expect there to be like a comma here or something that says like we have a function that takes 2 parameters. But actually what we have here is we have a function that takes a single string as a parameter, which then returns, which is what this equal means, it returns another function which takes a string as a parameter, and this function then returns a string. So it's almost like you have a wrapped function definition. So you have this outer function that takes in prefix string, and this inner function that gets returned from that, which takes the base string and then returns the complete string. So then what you're doing here is you're saying, okay, I want to evaluate this first part of the signature and just take in the prefix string. And then once this gets evaluated, it returns the rest of the chain of parameter functions that are in that curried function definition, which allows you to perform this partial application. So now the output of this will actually let you print hello with anything that comes through this sequence.map operator. So you can actually define new functions in this way. So let's say let prefix with hello, and then we will assign that to prefix hello. And it's really that simple. Now this function just takes in a single string and returns a string. And if we use that prefix with hello here, and we evaluate this, then we evaluate this, now you see we get the same result. So we have all the hellos that we expect. And this is part of what I was talking about before when I said that one of the benefits of functional languages is that you get to build things based on functions. Like you're basically layering functions, or you're sort of using functions as your basic unit of abstraction. So if you can define a function that has multiple parameters, and you define the function in the correct way, where you do it in the right order, the parameters in the right order, then the users of your function can then make certain parameters of your function static by doing this partial application, and then pass those functions into other operations. So this is one way where you could sort of like pass around dependencies without your downstream code having to know how to get that variable. You can sort of just bake it into your function calls or your function definitions. So there's a lot of really interesting things that we can do with this, and I'm planning to show a little bit more of that later in a couple of the future videos. So now let's go a little bit further with the pipelining operator, because I think it's pretty cool. Let's define a new function called exclaim. And all this function is going to do is take in a string, and it's going to return that string followed by an exclamation point. Pretty simple, right? So now what we can do is we can continue this pipeline by saying pipeline operator, sequence.map, exclaim. Now that we have this pipeline set up, basically what happens is that for each item in this names list, we're going to send it through, we're going to send this whole variable names through sequence.map, and for each item in that list, we're going to run prefix with hello on it, and then the result of this is going to go through the next sequence.map, which is going to run exclaim. So we should be able to build up these strings progressively like this. So if I go and run, actually let me evaluate exclaim first, and now I'll go and run this code, and now you'll see that all of our strings have exclamation points at the end. So I really like this pipeline operator. This is sort of one of my favorite features of F# because it really makes it easy for you to build up these layers of computation just using these simple functions. Like I was saying before, you can build more complex behavior just by using these sort of composition of functions. So we can do one more example of this. We can actually say pass this through sequence.sort and run this, and now you'll see that the list of names that comes out is actually sorted. So you can do basically whatever you want here. I mean, you can just keep piping things through. You can do a lot of really interesting things with this. So now let's show what it really means to do function composition. So we can do function composition in F# by defining a new function. So let's say we're going to create a function called big hello. And really all we want to do in this function is just take prefix with a hello and exclaim and just merge them together in one function. So I'm going to say prefix with hello, and then use the reverse composition operator to pass it through exclaim. And now what I've done is I've returned a new function, which basically just takes these two functions and puts them together. So the function that's returned calls prefix with hello first, then takes the output of that and then passes it into exclaim, and then this function returns whatever the return value of exclaim is. And you can tell the direction of the composition based on the direction of the arrows. So if I was to do it this way, it would actually call exclaim first, then return the value to prefix with hello, and then return its result as the result of big hello. So the arrow of these operators is actually, the direction of these arrows is actually important. So now if we actually take this big hello function, we can just knock this part out, then change this to big hello, and then run this function, and then reevaluate this, we'll see that we get the same result. And it's also sorted still because we're just passing it straight through sort. So you can do a lot of really interesting things by just building up new functions based on previous functions. But like I mentioned before, you can take small functions which have a single purpose and then combine them together with other functions to create more complex behavior. So like this exclaim function is really simple, and it's not something you would normally use in reality, but you could take this and put it with many other functions. So it could be a completely different prefix function or any other string related function you could use exclaim with. So instead of having sort of like large blocks of code that do a lot of behavior that is very specific to a particular implementation, you have these small little pieces of code around that you can sort of plug together like Lego blocks whenever you need them. One other thing that is interesting to mention about this kind of design is that if you were to do the same thing in C#, probably what you would end up with is like a class hierarchy where you have like an abstract base class, which, like it's like a string generator. Then you would derive from that with the prefixer generator or something, and then you might derive from that with the exclamation prefix generator or something like that. So with C# and other object-oriented languages, it sort of encourages you to use classes as your way to make these kinds of various different behaviors. What I like about functional languages like F# is that it actually allows you just to use functions. So it's really simple to be able to put together this kind of functionality without having to do a lot of complicated work or write a whole lot of code. I mean, this is really simple code for what we just accomplished. So one last thing that I'd like to talk about here is the way that this sequence stuff works. So the sequence module in F# contains a bunch of functions that operate on sequences like, lists or pretty much anything else that could be enumerated. The important thing to know about them is that they are lazily evaluated. And if you have used link in C# at all, then you're probably familiar with this because it's sort of similar. But this chain of sequence operators actually does not get evaluated until something tries to iterate over it. So to make that more clear, what I'll do is I will put a print statement in with this map. So what I'll do here is make an anonymous function that takes in a parameter called x, and then I will print. Actually, let me print f. I will print x, and then I will pass x through big hello so that the value still passes through. So one thing to note about function definitions in F#, you can have as many expressions as you want inside of a function, but only the last one actually defines what value gets returned by the function. So if I just evaluate this now, it won't seem very surprising because it will actually just print it out immediately. But if I assign this to a variable, let's say call this hellos, and then evaluate this, you'll notice that it didn't actually print the mapped over strings. It printed out the code that it evaluated, but it didn't print anything. So what happens if I just evaluate hellos now? If I evaluate hellos, the prints actually happen. So the reason why evaluating hellos actually made this happen is that the F# formatting system will enumerate over the value so that it can print it out. So just to produce this string, it will enumerate over the sequence that is in this name, and then basically just cause a printf function to get executed. So this may be something that would be confusing, like if you try to store this the result of a sort and a map operation into a variable. You might think that it's already done, but it may not be done. So if you're expecting like side effects to have some impact on variables inside of your pipeline, then you may want to make sure that you're doing some iteration over the variable to make sure those things happen in effect. So if you want your collection to be iterated over immediately, then you need to use this seq.iter function. So if I call seq.iter, then you basically need to pass in a function to seq.iter so that it will run something on every item that comes through the list. So in this case, we can actually just say printfn and just pass a string right through. So whatever comes through will just get passed through here. So if I run this, you'll see that we're getting printed the mapped over variables and also the hellos. And then one thing you'll notice here also is that the first map seems to have fully completed before the prints from the second map, or the iter actually have completed. So each one of these is completing its operation before it gets passed through to the next one. And because the iter function actually returns a unit, which like I said before is like the void for F#, the hellos variable actually doesn't have the list of things mapped in it anymore. It only just has just like this empty variable. So hellos is kind of useless at this point. So that's it for our introduction to basic functional programming concepts with F#. We'll go into some of these things in more detail as we progress through the series. The cool thing about functional programming is that it's a totally different way of thinking about how to design your code. And it actually helps you to see everything differently in the way that you design even your code that you write in object-oriented languages. It teaches you how to think in terms of layering behavior and using composition to make more complex behavior, but by making it using really simple building blocks. So having a really simple function that can be used with other functions to make more complex behavior. So it makes you sort of maximize the reusability of your code, and also makes it more testable because you have things that are, small units that do one specific thing and can be tested independently. So before I wrap things up, I would like to ask for a couple favors from you. If you enjoyed this show, please click the red subscribe button below because I'm going to be making more of these videos, not only about F#, but about other programming languages and development tools, etc. So if you subscribe, you'll get notified as soon as I post new videos. The other thing is that I would really love it if you would share this video with your dev comrades on social media and elsewhere so that we can get more people involved in this conversation so that we all benefit from it. So I really hope that you enjoyed this initial introduction into functional programming with F#. In the next episode, we're going to delve more into F#'s unique features, and we're going to use them to start a really cool game application using the language. So that's it for this first episode of the Dev Aspect. Thanks a lot for watching, and we'll see you next time.